Hello everyone, in this video we're going to learn how to solve exponential and logarithmic equations and inequalities. Alright, so before we're going to start, let's review some formulas that needed for you to master this concept. Alright, the first formula you need to know is the exponential product property. Right, so we have a raised to the m times a raised to the n equals a raised to the m plus n. Now, if you have a raised to the m all together raised to the n, and then this guy is called power property. So it's going to be a raised to the m times n. Next one, if you have the negative powers, so for example, if you have a raised to the negative m, right, you need to make it positive, you just flip it, so it's going to be 1 over a raised to the m. Right, if you have a over b raised to the negative m, now you need to make it positive, you just flip the fraction, so it can be b over a raised to the m. Alright, so when it comes to the logarithmic property, we have the product property. If you have log base a of m times n, and then this guy turns out to be log base a of m plus log base a of n. Now, if you have the quotient property, log base a of m over n, this guy turns out to be subtraction. So it's going to be log base a of m minus log base a of n. Now if you have log base a of b power of m, alright, so you can print this one to the front. It turns out to be m times log base a of b. Now if you have log base a power m base b power n, so this guy turns out to be n over m log base a of b. Now if you have log base a raised to the power m of b, then this guy turns out to be 1 over m log base a of b. You have the formula between the exponential form and the logarithmic form. So if you have a raised to the b equals c, and then you can convert this one into the logarithmic form. So this guy turns out to be log base a of c equals b. So keep this formula in mind. You can convert back and forth. Alright, so let's take a look at the first example. So for example, I need to solve for s 16 raised to the 3s equals 8. Alright, so we have 3 different ways to solve this one. Now, the first way, we just convert this guy and this guy in the same base. Right? So I have 16 right here. This guy turns out to be 2 raised to the power of 4 all together power of 3s. Right? This guy right here, 8, turns out to be 2 power of 3. Right? Now, I'm going to use the power rule right here, the second formula. So it turns out to be 2 raised to the 4 times 3 is going to be 12s equals 2 raised to the power of 3, right? Now, this is exponential equation, and if they have the same base right here, 2, then you just equate the exponent, right? So I have 12s equals 3. Divide both sides by 12. So s equals 1, 4. Alright? Now the second way to solve this one is to take log both sides, right? So I have 16 raised to the 3s equals 8. So I look at this one. I see this one is 16, right? Now I need to bring 3s to the front, so I need to take log base 16 both sides, right? So this guy is 16 of 16 power of 3s equals log base 16 of 8. Alright, now 3s bring to the front by using the formula right here. Alright, so I have 3s log base 16 of 16 equals. Now this guy right here, log 16 I can write as 2 power of 4, right? And 8 right here I can write 2 power of 3, right? Now I have the formula log base a of a always equals 1, because this guy the same thing, it's gonna be 1. So log base 16 of 16 is gonna be 1, right? So the left hand side only have 3s left equals. Now the right hand side I'm gonna apply the formula right here. Alright, so it turns out to be 3 over 4 log base 2 of 2, right? So log base 2 of 2 is going to be 1, right? I use this formula. Alright, so this guy, I don't need to write it. Alright, so I need to solve for s, divide both sides by 3, so s equals 1 over 4. Alright, now the third way, you just print up the calculator. So you hit add graph right here, okay? F1 of s, you just input the 16 raised to the 3s. So 16 raised to the 3s. And hit enter. So this is the graph. Now for the second one, you just hit tab and you hit 8. Alright? And you hit enter. Now it doesn't show up because the window range doesn't fit this graph, right? If you look at this one, you see that the maximum is just 6.67. Now we need 8, right? So you need to hit menu, go to window, zoom right here, and then you need to hit window setting. Alright, so the maximum right here, you need to adjust this, so you just hit 10 and hit OK. So the graph right here. Alright, so you need to find the intersection. You just hit menu, analyze graph right here, and then number 4 intersection right here. Now you move the line to the left of the intersection right here, you hit enter. Now move the line to the right of intersection, hit enter. And then you get the intersection right here. It's going to be 0.25, which is 1/4, right? It's right here. Now let's move on to the next example. So for example, we need to solve 2 raised to s plus 3 plus 5 equals 26. Alright, so the first thing you need to do is to subtract 5 both sides. So it's going to be 2 raised to the s plus 3 equals 21. Alright, so you look at the base right here, it's going to be 2, right? So you need to take log base 2 both sides, right? So I have log base 2 of 2 raised to the s plus 3 equals log base 2 of 21, right? Alright, so I use this formula right here. I need to bring s plus 3 to the front, right? So I have s plus 3 altogether times log base 2 of 2 equals log base 2 of 21, right? Now log base 2 of 2 is going to be 1, right? So I don't need to worry about this one. So I have s plus 3 equals log base 2 of 21. Now I need to subtract 3 both sides, so s equals log base 2 of 21 subtract 3. This is the final answer. Now let's move on to the next example. For example, I need to solve negative 7 equals 3 minus 4 times e to the s, right? So I just rewrite this one. So it turns out to be 3 minus 4 times e to the s equals negative 7, right? So the first thing I need to do is I need to subtract 3 both sides. So it will be negative 4 times e to the s equals negative 10. And then divide both sides by negative 4. So e to the s is 10 over 4. So e to the s equals 5 over 2, right? So I look at the left hand side right here. I need to solve for s, right? So I look at the base right here, e. So I need to take natural log both sides, right? So natural log of e to the s equals natural log of 5 over 2. Now keep in mind, natural log, which means log base e. Alright, so this guy is the same thing as log base e of e, right? So I just bring s to the front, so I have s natural log of e equals natural log of 5 over 2, right? Natural log of e, which means log base e of e, right? So it's going to be equal to 1. Alright, so this guy equals to natural log of 5 over 2. Alright, now let's move on to the next one. We need to solve the logarithmic equation. Alright, so I have 2 log base 3 of s plus 3 plus 4 equals 10. Now the first thing you need to do is to subtract 4 both sides, right? So I have 2 log base 3 of s plus 3 equals 6, right? And then divide both sides by 2. So I have log base 3 of s plus 3 equals 3, right? Now we know that log base a of b equal to c, right? So in order to convert it to exponent, you're going to do like this. A raised to the c equals b, right? So you draw an arrow like this. So you have s plus 3 equals 3 raised to the third, right? Now 3 raised to the third is going to be 27, right? Now subtract 3 both sides, so s equals 24, right? Now let's move on to the next example. For example, we need to solve natural log of 2 minus s over 5 equals 1. Alright, so you need to isolate natural log of 2 minus s by multiplying both sides by 5, right? So natural log of 2 minus s equals 5, right? And then natural log of 2 minus s is the same thing as log by e of 2 minus s equals 5, right? And then you just draw an arrow right here, and then 2 minus s equals e to the fifth. And then subtract 2 both sides, so it could be negative s equals e to the fifth subtract 2. And then divide both sides by negative 1, so s equals 2 minus e to the fifth. Alright? Now, let's move on to the next example. So, we have the formula log base a of s equals log base a of y. Then s equal to y. keep that in mind. We have the same base right here. We have the same base. So s should be equal to y. Alright, so let's move on to the next example. Log 3 plus log s plus 4 equals log 5s minus 2. Alright, so first you need to find the domain, right? Now the domain of the logarithm, log base a of b is going to be a greater than 0, a different from 1, and b greater than 0. Alright, so keep this one in mind. Now, if you just write log only like this, which means log by 10, right? So this guy 10 greater than 0. That's pretty good already, right? So you don't need to write 10, right? Now, we need this guy greater than 0. This guy greater than 0. 3 already greater than 0, right? So domain s plus 4 greater than 0, 5s minus 2 greater than 0. Alright, so this guy turns out to be s greater than negative 4 and s greater than 2 over 5. Alright, so we just combine this one. This guy turns out to be s greater than 2 over 5. Right? Because when you draw a number line, you put these two numbers on the number line. So negative 4 right here and 2 over 5 over here. And then s greater than negative 4, which means you need to eliminate every single thing on the left hand side. Right? You only take from here all the way to the right. Now s greater than 2 over 5. Right? So it's going to be from here all the way to the right. And then you need to eliminate this guy. Right? So final answer should be 2 over 5. That satisfies both conditions right here, right? Alright, so we're gonna apply the formula right here to condense this one. Alright, so this one you already learned in the logarithmic property. If you forget how to do it, just check out the video in the description below. Right? So this one is addition, turns out to be product, right? The formula right here. So I have log of 3 times s plus 4 like this equals log of 5s minus 2, right? Now, both sides have the same log and then same base 10, right? Base 10. So you just use the formula right here. You equate s and y, right? S in this situation is going to be 3 times s plus 4. And then y in this situation is going to be 5s minus 2. And you just solve multi-step equation and you're done, right? So distribute this one is going to be 3s plus 12 equals 5s minus 2, right? And then subtract 5s both sides and subtract 12 both sides. It turns out to be negative 2s equals negative 14. And then divide both sides by negative 2, so s equals 7, right? Now we check to see if this guy in the domain, right? We need s greater than 2 over 5, and we get s equal to 7. So this is the solution, right? Because it satisfies the domain, right? Now let's move on to the next example. For example, I need to solve natural log of s plus 1 minus natural log of 3s minus 5 equals natural log of 7, right? Now I look at this one, I need to find the domain first, right? So the domain is going to be s plus 1 greater than 0 and 3s minus 5 greater than 0, right? So this guy turns out to be s greater than negative 1 and it's s greater than 5 over 3, right? Now I put this guy on the number line. right? So I have -1 and 5 over 3. It's going to be -1 right here, 5 over 3 right here. Now s greater than -1, so which means from here all the way to the right, right? Eliminate this. Now s greater than 5 over 3 is from here all the way to the right, right? So you need to plot this one out, right? And I need to pick s greater than 5 over 3. That satisfies both conditions, right? So s greater than 5 over 3 is my domain, right? Now I need to solve this one using the logarithmic property, right? So this is subtraction turns out to be quotient, right? So it's going to be natural log of s plus 1 over 3s minus 5 equals natural log of 7, right? Now I just apply the formula right here. So I have s plus 1 over 3s minus 5 equals 7, right? Alright, I need to multiply both sides by 3s minus 5. So it turns out to be s plus 1 equals 7 times 3s minus 5. I know that's 3s minus 5 not equal to 0 because the domain right here guarantee that 3s minus 5 greater than 0, right? So then I just distribute the right hand side. So it could be s plus 1 equals 21s minus 35, right? So this guy turns out to be negative 20s equals negative 36, right? Divide both sides by negative 20, so s equals 36 over 20. And then I just divide the top and bottom by 4, so it could be 9 over 5. Now I check my domain right here. S greater than 5 over 3. Now I get 9 over 5 right here. Which is, this satisfies the domain, right? So this is solution. Let's move on to the next example. Alright, so for example, we need to solve log base 3 of s plus 2 plus log base 3 of s minus 3 equals log base 3 of 14. Alright, now we need to find the domain first, right? So the domain is going to be s plus 2 greater than 0 and s minus 3 greater than 0. Alright, so this guy turns out to be s greater than -2 and s greater than 3. Now if you combine this one, the answer must be s greater than 3, right? So this is your domain. Alright, so I'm going to use the sum to convert it to product, right? So it turns out to be log base 3 of s plus 2 times s minus 3 equals log base 3 of 14. Okay, so I just use the formula right here. I just equate s plus 2 times s minus 3 equals 14. Alright, now you need to expand this one and then turn this one into quadratic equation. Now the common mistake students do it. They're gonna do like this: s plus 2 equals 14 and s minus 3 equals 14. This is wrong. This is not the zero product, so you're not gonna apply this formula. Okay, so distribute this one. It turns out to be s squared minus 3s plus 2s minus 6, and then subtract 14 both sides, right? It's going to be equal to 0. So simplify this one. It turns out to be s squared minus s minus 20 equals 0, right? And then I'm going to use the s method to factor this one out, right? So I put s method right here, put negative 20 right here, and this is negative 1. Alright, keep in mind this is C and this is B. Now I need to find two integers multiply equals negative 20 add up to negative 1, which is negative 5 and 4, right? So this guy turns out to be s minus 5 times s plus 4 equal to 0. Now this is the 0 product, and then you can say s minus 5 equals 0, or s plus 4 equals 0. Alright, so s equals 5, and then s equals negative 4. Alright, now you look at the domain right here. We need the number that's greater than 3, so only this one satisfied. So this guy is the solution. And this guy is not a solution. This guy is called extraneous solution. Now let's move on to the next example. For example, I need to solve natural log of s minus natural log of 3 equals 2, right? The domain is going to be s right here greater than 0. That's it, right? So I'm gonna turn the subtraction into division, right? So it can be natural log of s over 3 equals 2, right? So then I'm gonna use the formula right here, a raised to the b equals c, right? So it's gonna be, this guy actually log base e, right? So I have e squared equals s over 3, right? Alright, so I'm going to multiply both sides by 3, so it could be s equals 3 times e squared. Alright, and this guy greater than 0, so this guy is the solution. Now let's move on to the next example. For example, I need to solve log base 4 of s minus 3 log base 4 of 2 equals log base 4 of s plus 2, right? Now I look at the left hand side, I see this guy has the subtraction. So I need to turn this one into division. So in order to do that, I need to make the coefficient in front of log equals 1, right? So I have 3 right here, I need to bring 3 back over here, right? By using the formula right here, right? You just bring m back over here, and it turns out to be this one. Alright, so this guy turns out to be log base 4 of s minus log base 4 of 2 power 3, right? Equals log base 4 of s plus 2, right? Alright, so you know that 2 power 3 is going to be 8, right? So this guy turns out to be log base 4 of s over 8 equals log base 4 of s plus 2, right? And then you just equate this guy and this guy, right? By using the formula right here. So s over 8 equals s plus 2. Alright, so you need to multiply both sides by 8. So it can be s equals 8s plus 16, right? So subtract a at both sides, so it can be negative 7s equals 16. So then divide both sides by negative 7, s equals negative 16 over 7, right? Now, we need to go back over here, we need to find the domain, right? So the domain is going to be s right here greater than 0, right? And then s plus 2 right here greater than 0, right? And then you have s greater than 0, s greater than negative 2. Now you need to combine this guy, so it's going to be s greater than 0, right? Is the domain. Now you have the negative solution right here, so this is not solution. Then the original equation has no solution. Now let's move on to the next example. For example, I need to solve log s minus 2 equals log s minus 7, right? Now I need to find the domain. So the domain is going to be s greater than 0, this guy right here, and s minus 7 greater than 0. Now this guy turns out to be s greater than 0 and s greater than 7. Now I need to combine it, so it's going to be s greater than 7, right? Is the domain. Now I look at this one and see that log s on the left hand side, and I have a number right here, and on the right hand side I have log s minus 7. So I need to bring log to the left hand side, right? So it could be log s minus log s minus 7. And the right hand side I just add 2 both sides, so it could be 2 right here. Alright, so then I can apply the quotient rule, right? So it could be log s over s minus 7 equals 2, right? Now keep in mind, if I just write log like this, which means log base 10, right? So this guy I just put 10 right here, right? So I just draw an arrow like this. So it could be s over s minus 7 equals 10 power of 2. It could be 100, right? And then I'm going to multiply both sides by s minus 7. So s equals 100, s minus 7, 100, right? So subtract 100 both sides, it could be negative 99, s equals negative 700. And then divide both sides by negative 99. So s equals 700 over 99. Now 700 over 99 is greater than 7, right? The domain right here. So this is a solution. Alright, so let's move on to the next example. For example, we need to solve log base 3½ of x plus 1 minus log base 2/3 of 2x plus 3 equals log base 2/3 of 2. Now I look at this one, I see the base right here, 3½ 2/3 and 2/3. Now I need to make them all the same base, so I need to apply the formula right here and the formula right here. Alright, so what should I do? I need to rewrite the first one, log base 3½ of x plus 1 minus. Now this one right here, I can rewrite this one as power of 1, right? So I use the formula right here to make it 3½. So it could be log base 3½ power of negative 1, right? Of 2x plus 3 equals log base 3½ of power of negative 1, right? 2 right here. Alright, so then I'm gonna apply the formula right here. I bring m to the front, it turns out to be 1 over m, right? So this guy turns out to be log base 3½ of x plus 1. Now negative 1 bring to the front, it turns out to be 1 over negative 1, which is negative 1. Negative 1 and negative side right here turns out to be positive side, so it could be like this. Log base 3½ of 2x plus 3. Alright, now this guy, same thing, it turns out to be negative log base 3½ of 2, right? I use the product formula right here to combine this guy. So this guy turns out to be log base 3½ of x plus 1 times 2x plus 3 equals, now negative side right here, which means negative 1, I can bring this back over here, right? So it turns out to be log base 3½ of 2 power of negative 1, so that I can use the formula right here, right? So this guy turns out to be x plus 1 altogether times 2x plus 3 equals 2 power of negative 1, right? Which is 1/2, right? Now I'm going to distribute this one, so it turns out to be 2x squared plus 3x plus 2x plus 3, and then subtract 1/2 both sides, so it could be like this, equals 0, right? And then I'm going to combine like terms, so I have 2s squared plus 5s plus 5 over 2 equal to 0, right? Now I need to multiply both sides by 2, so I have 4s squared plus 10s plus 5 equals 0, right? Now I'm going to use the quadratic formula to solve this one, right? So I have s1 and s2 equals negative b plus minus square root of b square minus 4ac over 2a. Now I just substitute the value, so s1 and s2 equals negative b, which means negative 10, plus and minus square root of b squared, which means 100, right? Minus 4 times a times c, minus 4 times 4 times 5, right? Over 2 times 4, right? Now I just simplify this one, so s1 2 equals negative 10 plus minus. Now 4 times 4 equals 16 times 5 is going to be 80. So 100 subtract 80 is going to be 20. So the plus and minus square root of 20 over 8, right? Now square root of 20, which means square root of 4 times 5. Now 4, you can bring it outside. It turns out to be 2, right? So this guy turns out to be s1, 2 equals negative 10 plus and minus 2 root 5 over 8, right? Now you can simplify this one further, right? So it turns out to be s1, 2 equals negative 5 plus and minus square root of 5 over 4, right? Now we look at this one right here. We need to find the domain, right? So the domain is going to be s plus 1 greater than 0 and 2s plus 3 greater than 0. Alright, so this guy turns out to be s greater than negative 1 and s greater than negative 3.5. Alright, so if you combine this one, it turns out to be s greater than negative 1 is the final domain. Alright, so we look at this one, we have two values right here. The first value is going to be s1 equals negative 5 plus square root of 5 over 4. And the second one, s2 equals negative 5 minus square root of 5 over 4. Now we check with the domain, we see that this guy greater than negative 1. This guy less than negative 1. So this guy is not a solution. The solution is this guy right here. Alright, let's move on to the next example. Now, we need to find the intersection of these two graphs right here. Alright, so you can use a calculator to find the intersection easily, like what I did in the first example, right? Now, what if you're not allowed to use a calculator on the AP exam, right? So we just do this one manually. So how do we do this one? You just equate this guy and this guy. So I have natural log of s plus 15 minus natural log of s equals natural log of s plus 3, like that, right? So then I use the quotient rule to condense this one. So it will be natural log of s plus 15 over s equals natural log of s plus 3, right? And then I just equate both sides using the formula right here. So s plus 15 over s equals s plus 3, right? Now I need to multiply both sides by s, so it can be s plus 15 equals s squared plus 3s. And then I need to convert this one into quadratic equation. So this guy turns out to be s squared plus 2s minus 15 equals 0, right? And then I need to factor this guy out using the s method, right? So I need to put c equals negative 15 right here and b equals 2, right? And then I need to find two integers, multiply equals negative 15 add up to 2. So it's going to be 5 and negative 3, right? So this guy turns out to be s plus 5 times s minus 3, right? Equal to 0. And this is the 0 product, so I have s plus 5 equal to 0, or s minus 3 equal to 0. And then I need to solve for s, so s equals negative 5 and s equals 3. Now, don't forget to find the domain, right? The domain of this one, s plus 15 greater than 0, s greater than 0 right here, right? And then s plus 3 greater than 0, right? Now this guy turns out to be s greater than negative 15, s greater than 0, and s greater than negative 3. Alright, so if I need to combine these three guys right here, the final answer for the domain s must be greater than 0, right? This is the domain. Now I have two solutions right here, only this one satisfied, right? So solution is s equals 3. This is not a solution, right? I need to substitute s equals 3 into one of this equation. So I just substitute over here. So I have g of 3 equals natural log of 3 plus 3, it can be natural log of 6, right? So I have the intersection is 3 comma natural log of 6. Now let's move on to the next example. S over 3 raised to the 3 plus log s equals 3 times 10 to the 4. Alright, so of s over 3 altogether raised to the 3 plus log s equals log 3 times 10 to the 4, right? And then I'm going to use the formula right here to bring this guy to the front. So it's going to be 3 plus log s altogether log s over 3, right? So this is the quotient. I can apply this formula to turn this one into subtraction. So it's going to be log s minus log 3, right? Now, the right hand side right here, I can use the product rule right here. So it's going to be log 3 plus log 10, right? Power of 4. But 4, I can use this formula right here to bring m to the front. So I bring 4 to the front. So it's going to be 4 right here, right? I just use the chain of variables. So I let log s equals a, right? So this guy turns out to be 3 plus a times a minus log 3 equals log 3 plus 4. Because log 10 is the same thing as log base 10 of 10, and this guy equals 1 based on the formula right here, right? So I just distribute this one and turn this one into quadratic equation, right? So I have 3a minus 3 log 3 plus a squared minus log 3 altogether times a equals log 3 plus 4, right? Now I need to subtract log 3 plus 4 both sides, right? So this guy turns out to be subtraction, and this guy equal to 0. Now I need to rearrange this one into the quadratic equation. So it could be a squared Now this guy has the variable a, so I combine this guy, so it turns out to be plus parentheses 3 minus log 3. Okay, factor a out, right? And then this guy right here and this guy right here, I combine these two guys, so it's gonna be negative 4 log 3. And then minus 4 right here equals 0. Now this guy turns out to be quadratic equation. Alright, so we have two solutions. S equals minus b plus minus square root of b squared minus 4ac over 2a, right? And then I just substitute negative b. b in this situation is going to be this guy right here. So it's going to be negative parentheses 3 minus log 3 plus and minus square root of b squared, which means 3 minus log 3 altogether square, minus 4 times a. a in this situation is 1. And c in this situation, this one right here. So it's going to be negative 4 log 3 minus 4 over 2 times a equals 1, right? Alright, so we need to simplify this one. So I just distribute negative 1. So it turns out to be s equals log 3 minus 3 plus and minus square root of, now this guy square equals 9 minus 6 log 3 plus log 3 altogether square. This guy you need to distribute negative 4, so it's going to be plus 16 log 3 plus 16 over 2. Alright, so it's going to be log 3 minus 3 plus and minus, now log square root of, now log 3 square, I just rewrite log 3 altogether square. Now this guy right here and this guy right here, I simplify it, so it's going to be plus 10 log 3, right? And then 9 plus 16 is going to be 25, right? Over 2. Now 3 terms in the radical side right here turns out to be a complete square, right? Remember, if I have a square plus 2ab plus b square, it's going to be a plus b altogether square. A in this situation is log 3, b in this situation is 5, right? So this guy turns out to be log 3 minus 3 plus and minus square root of log 3 plus 5 altogether square over 2, right? Now log 3 plus 5 is a positive number, so when you take square root of log 3 plus 5 altogether square, it turns out to be log 3 plus 5, right? So this guy is going to be log 3 minus 3 plus and minus parentheses log 3 plus 5 over 2. Now I need to simplify this one, so it turns out to be log 3 minus 3 plus log 3 plus 5 over 2. And the second case, log 3 minus 3 minus distribute negative side, so it could be negative log 3 minus 5 over 2. Alright, so this guy turns out to be log 3 plus log 3 is going to be 2 log 3, right? And then negative 3 plus 5 is going to be plus 2 over 2. And the second one, this guy cancel out. Negative 3 minus 5 is going to be negative 8. Divided by 2 is going to be negative 4, right? Alright, so the first one right here, you just divide the top and bottom by 2, right? So this guy turns out to be log 3 plus 1 over 1, right? So over 1, I don't need to write it. Alright, so I have two solutions right here. Alright, so now I need to go back to original one. Original one is going to be a equals log s, right? Oh, I forgot. This guy should be a because the variable is a, right? A right here. So I have log s equals log 3 plus 1, right? This is a equals two values right here, but a equals log s, so I just substitute log s back into the equation right here. And then the second case is log s equals negative 4, right? And then this guy turns out to be, this guy actually a number, right? So this guy base 10, right? So I put 10 right here, I put 10 right here, right? I draw an arrow right here. So s equals 10 to the log 3 plus 1, right? And then this guy turns out to be s equals 10 to the power of negative 4, right? Now this guy is already in the simplest form, so I leave it. Now I need to simplify this one further. So I'm going to apply the formula right here. I need to split this one. So this guy turns out to be 10 to the log 3 times 10 power of 1, right? Now I'm going to apply the formula right here. If I have a raised to the log base a of b, and then this guy turns out to be b. Now this guy means base 10, right? So a in this situation equals 10, right? So this guy turns out to be 3 times 10, and it's going to be 30. Alright, so I have two solutions. The first one is 30. The second one is 10 power of negative 4. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.